Source transformation is a way to replace one source model by another model that looks the same from the outside terminals. A voltage source Vs in series with a resistor R can be replaced by a current source Is in parallel with the same resistor R. The value is Is equals Vs divided by R. In the reverse direction, a current source Is in parallel with R becomes a voltage source Vs equals Is times R in series with R. Only the external behavior is preserved, so the load connected to the terminals sees the same voltage and current. Now use the method on a mixed source circuit. The target voltage V is measured at the right node, plus at the top and minus at the bottom. On the left, a 6 mA current source is in parallel with 1.4 kOhms. On the right, a 1 mA current source points downward and is in parallel with 3 kOhms. Those two source resistor pairs can be transformed, while the 0.6 kOhm resistor and the 1.4 volt source stay in the top branch. Transform the left Norton pair first. 6 mA times 1.4 kOhms gives 8.4 volts, with the top terminal positive because the current source injects current upward into the top node. The parallel 1.4 kOhm resistor becomes a series 1.4 kOhm resistor. For the right pair, the 1 mA arrow points downward, so the top terminal is negative in the Thevenin form. 1 mA times 3 kOhms gives 3 volts, with minus at the top and plus at the bottom. After both transformations, the circuit becomes one series loop. The total resistance is 1.4 kOhms plus 0.6 kOhms plus 3 kOhms, which is 5 kOhms. Following the loop direction, the sources combine as 8.4 volts minus 1.4 volts plus 3 volts. That net source is 10 volts. Therefore, the loop current I is 10 volts divided by 5 kOhms or 2 mA. The current through the 3 kOhm resistor is 2 mA. So the voltage across that resistor is 3 kOhms times 2 mA, which is 6 volts. The output node is not directly across the whole 6 volts because the 3 volt source on the right has minus at the top and plus at the bottom. With the marked polarity, V equals 6 volts minus 3 volts. The requested output voltage is therefore 3 volts. The process is systematic. First, identify a source and resistor that are strictly in series or strictly in parallel. Second, convert with I equals V divided by R or V equals I times R, keeping the same resistance. Third, track polarity and arrow direction carefully. In this example, the downward 1 mA source is what makes the right Thevenin source have minus at the top. That sign is why the final output is 6 volts minus 3 volts equal to 3 volts.